Okay, so there you have your four energy levels. Determine the wavelength of light produced by transitioning from E3 to E2. Right, so E2, and then here we have E3. This is A8 now. So we are going from E2 to E3. So E3 to E2. So E3's level was minus 2.416 times 10 to the minus 19 joules, and E2's level was minus 5.424 times 10 to the minus 19 joules. So here there was a loss of 5.424 minus 2.416. So there was a loss of 3.008 times 10 to the minus 19 joules. Now where did this missing energy go?
8. What did you say?
3.008 10 to the minus 19. Where did this missing energy go? Where? No heat. No. As the photon. It was released as a photon. So the energy of the photon will equal hf. And what do they want? The wavelength. So energy equals hc over lambda. So then the lambda equals hc over E. Yeah. Now let me just double check it. What's the constant for H? It's number 6. Times the constant for C, number 28. Divided by the energy. We'll see if you're right. What did you get? 0.66. Oh, give it to me in nanos. 660 nanometers is what I got. And when I check, that is correct. Yes. Okay, so that's the A part of it, A part 1. Continue. A part 2. What is the energy of the photon emitted in an Okay, so A part 2 is the same, except it's from E4 to E2. And you have to convert. So E4 to E2. What's that? Because there's less formulas to use. E4 yeah, but let me just get the energy first. 4.064 times 10 to the minus 19 joules. So in electron volts, no. Yes. 2.54 electron volts. Is that what you got, Tekken? Yes or no? Okay. That's the correct answer. What did you get? Oh no. Something went wrong for you. Okay. And then part 3. Okay, so this question here is they want to know, explain why transition to the E1 level will result in UV. So, it doesn't say from where to E1. So we have to decide, should we go from E2 to E1 or E4 to E1? We will go from E2 to E1 and we'll show that E2 to E1 is ultraviolet. That means E3 and E4 must be at least ultraviolet as well. because they would have more energy because it's a bigger jump. So if we can show that E2 to E1 is ultraviolet, then E3 and E4 to E1 are also ultraviolet or greater. So what's the difference from E2 to E1? That would be 5.424 minus 21.73. So that would be 16.
Which is in the response.
16.306. What's that?
Which is in E2 because it's going to be higher.
No, because it's going to be the lowest. And if I can show it's ultraviolet for that transition, then it must be at least ultraviolet for the other transitions, because the other transitions would have even more of the energy in the photon, which means more frequency, which means even higher than ultraviolet. Okay, so E equals HF, so that means F will equal the E which we have, or the delta E if you want, over H. So that equals 2.46 times 10 to the 15 hertz. And then if I convert that into a wavelength, that's 121 nanometers is the wavelength. And I think purple is like 150, 200? Yeah. So if purple is about, 250, then what's just before that is ultraviolet on the wavelength. So I think, I don't remember, but I think...
0 to 3 something.
Hang on, let me think. It goes red, orange, yellow, green, blue, indigo, and violet. So I think that's something like 650 nanometers, and violet is like 250 nanometers. So that means 121 nanometers would be ultraviolet. What's wrong? What are you checking? Ten to what?
380.
Yeah, 10 to 380. So 121 is within 10 to 380 nanometers. So it's not 250, it's probably more like 350 to 650. Anyways. Okay, next one now. Can I close this?
Yeah.
Yeah, we'll look at B.